Okay. Now, when we find the values of the inverse functions, right? It's kind of, if it says exact value, that should give you a clue. Where do they think you're getting these values from? Not the calculator, right? When it says exact, what does it mean? It means probably unit circle, because we want to have unresolved radicals, right? Things like the square root of 3 or the square root of 2. We don't want to turn into a decimal. That's what they mean, which is kind of like the clue meaning, don't just turn it into a decimal. The funny thing is, in their problems in the homework, they say use a calculator, which at first I thought was a mistake. Surely they're giving all these values that are clearly coming from the unit circle. Why would they tell you to use a calculator? But they do. And their answers in the back of the book are in terms of decimals. They're not in terms of the unit circle values. To me, I wish we would just use the unit circle values, because that's what's the point, right? Of using like -1/2 and the square root of 3 over 2. Clearly it's unit circle. But anyways. Right. When I see a problem like arc sine or sine to the -1 of -1/2, to me, the way I read it to myself, it's like saying, where does sine equal -1/2? Right? That's the way I'm reading it. Where does sine theta equal -1/2? And specifically, in which two quadrants would we be looking for? No, because what do we say? We're looking at sine in between. We were told it's going to be between -π/2 and π/2. So it's actually in these two quadrants is where you're looking. So in terms of the example, when it says where does sine equal -1/2, and we should say that's going to be in either quadrant 1 or quadrant 4. And unlike the problems we did a couple lessons ago, where we had to find two values, here, because we've limited the domain to just those quadrants, there's only going to be one place where the sine equals -1/2, right? It's not ambiguous. That was the whole point of doing this, limiting of the domain. So look at the unit circle and find in between here and here, what is the angle where sine equals -1/2? Okay, so 330, we're doing in radians. So 11π/6 is 11π/6 in between -π/2 and π/2? No. I mean, you would, instead of saying 11π/6, you would say -π/6, because we're using negative angles, right? So understand, you could subtract 2π if you want. So we expect answers in between -π/2 and π/2. Sure. That's how you find coterminal angles. So that would be -π/6. Right. For the second one, again, to myself, I'm reading it as, where does sine equal square root of 3 over 2? Specifically in quadrants 1 and 4, what's the angle measure in radians where sine equals √3 over 2? Look for the y-coordinate, π/3. Right. No, that's the cosine. Yeah.
What about, can you back to me or something?
Sure.
In quadrant 4, where it says -3 over 2,
Okay.
could you use the negative method for that?
No.
Can you explain more?
Because negative is not equal to positive. I mean, I'm not going to say, it says where does sine equal positive square root of 3 over 2? If it meant negative, it would say negative, right? But it's not either or. Okay. What about the last one? Where does sine equal 2? In between -π/2 and π/2, Drew. Okay. Where does sine equal 2? I'm just saying, tell me, where does sine equal 2? Where is the y-coordinate equal to 2? There's not one on there. It's not in the domain. Remember, it goes for the inverse function, sine inverse goes from -1 to 1. You can't take the sine inverse of 2. We know from the graph of the sine, it goes from -1 to 1, -1 to 1. So ask them the question, where does it equal to? No solution. It's not in the domain. No solution.